Hi, this is the video presentations presented by my group, and my group project is designing a collision detection system using mbed LPC1768. And the group member consists of me, Wong Junhao, and another two teammates, which are Fu Jiahui and Nick Wei. Abstract. Nowadays, car crash have caused a great deal of property damage and also casualties, which put the road safety on a serious risk. And also, the percentage and the number of accidents happening on the road is increasingly year by year. This is due to a few factors such as the careless driving, the bad weather, and also unforeseen obstacles. So nowadays, the current safety measures such as the seatbelt and also the airbag will only reduce the collision force but not prevent the accident to be happen. Hence, our objective of this project is to design and develop an effective collision detection system by using cloud programming software and embed LPC1768 to reduce the number of accidents happening and also decrease the percentage of accidents happening on the road. So from this system, the design is based on the mbed LPC1768 and also consists of an ultrasonic sensor and alarm circuit, where this alarm circuit is built out of a buzzer, a red and green LED light. So for this system, we also test experimentally in two situations, where the first situation is the distance of the object and also the distance of the object and also the system is out of the range, where the range we set it up as 10 cm, where the out of range means the distance between the object and also the system, or we call it as a sensor, is more than 10 cm. The second situation is when the object and also the system are in the range where it means that the distance is less than 10 cm. The overall results show that this system works perfectly and works correctly based on its coding. And the result that we get in this project is to prove that this system can help in decreasing the number of accidents happening and also decrease the percentage of accidents happening on the road by helping the driver to detect the object at the surrounding of the car and give a signal to it when there's an object nearby its car.
Hi, my name is Lim Wei. For introduction, microprocessors are integrated circuits that perform the operation of CPUs and are essential for the development of modern digital devices and systems. They operate by fetching, decoding, and executing instructions from memory in a loop and are classified based on their instruction set architecture. Microprocessor is smaller, quicker, and more efficient over the years. Next, a microcontroller is a small integrated circuit used in embedded systems to control the specific functions. It consists of a CPU, memories, and I/O peripherals. The LPC1768 is a powerful microcontroller from NXP Semiconductors. Based on the ARM Cortex-M3 architecture, is suitable for high-performance applications. Furthermore, an ultrasonic sensor is a device used to measure distance by emitting ultrasonic sound waves and calculating the time it takes for the echo to return after hitting objects. It is commonly used in applications such as proximity sensing in car parking systems, level measuring in tanks, and optical identification in robotics. This project proposed using the NXP LPC1768 microcontroller to construct a collision detector system using ultrasonic sensors for obstacle detection. The system comprised components such as ultrasonic sensor, a buzzer, two LED lights, and connectors and breadboard for integrating the device. Next, for the project designs, the collision detection systems use an mbed LPC1768 and ultrasonic sensors to identify obstacles near a car. The system alerts drivers with a buzzer and LED lights when an object is detected within a set of distance of 10 cm. The system uses clear programming software for efficient control, aiming to improve road safety by allowing drivers to take preventive action and avoid accidents. For the block diagram illustrates the system flow. The ultrasonic sensor measures distance and sends data to the LPC1768, which then activates the buzzer and LED to provide and visual alerts based on the detected proximity of obstacle. Before conducting the lab experiment, we use a schematic design app to connect the components virtually. The collision detector system, implemented using the LPC1768 microcontrollers, integrates an ultrasonic sensors and output device of LEDs and a buzzers. As shown in the schematic diagram, the sensor's VCC is connected to the VU pin on the LPC1768, GND to ground, TRIG to pin 15, and Echo to pin 16. The output device include a buzzer connected to pin 33, a green LED to pin 34, and a red LED to pin 25.
Good day, Doctor. I'm Fujiahui. I'm going to present my part, which is a coding for the collision detection system. In this coding, we are not include the LCD displays because we assume the LCD display is sent as the function for the buzzer and the LED. So to lower the budget, we are not to use the LCD. Besides, the other reason is the LCD displays in a vehicle collision detection system can be distract drivers' attention and make them lose concentrations on the road, which is very dangerous when we at the high speed or in the heavy truck speed. And also the system already include a buzzer and LED, which can effectively indicators potential collisions. For the coding first part, we are doing the system initializations, which is the pin selection, set the function of the pin. For example, pin 1 SSL is set the constant is defining the constant address for for the pin 1 SSL. Why we need to define the address? Because each register have the specified functions, and the address are used to access and manipulate those registers in the rest of the code. So it's a very important step we need to do. Next, for system minimize, we also have to select which the pin is as an output or input. For example, for the buzzer and LED, we are set as the output for in this system. When the system is detect the object, the buzzer and the LED will be lights out. So it will be set as the output. So we will do this one or set the input and output. We'll do in the FIO 2 direction and the FIO 0.0 directions, because we have used two different type of port, which is a port 0 and port 2. Port 0 is for the ultrasonic sensor, and the port 2 is for our buzzer and LED. So for the ultrasonic sensor, the trigger and echo will be set point 0.2T as the output trigger and point 0.224 as input, which is for the echo signal. And we also look the some resistor will be equal to the FIO pin, FIO set for the port 0 and port 2, and also FIO clear for the port 0 and port 2, and also the TC, which is the times control, and also the TR timing register. Now we are in the main part of the coding. In the main part of coding, we have the process which is weekly alert. This constantly to checking whether there's a presence of object on that, and to start this system, the ultrasonic sensor would be start working first, which is start to send a pulse to the trigger pin and to start the ultrasonic measurement. Then the trigger which have need some time to send it the signal. So we have at the delay time after the calling of the start trigger. After delay time, the we will be will be stop the trigger and start the reading the echo. Echo reading, which is the wait for the echo response, which indicate the system have detected an object. For the read, for the part of the read, this is a loop that wait for the echo signal to start. It read the value at the memory location pointed by register X, which is the address of the FIOP. The register for the reading the state of the port 0. Uh, it also performed a bitwise and operations. We register 1 which has been set to 1000000 corresponding to the pin for the echo signal, and compare the result with the register one. It means the echo signal has not started, so it's going back to the start of the read loop. And then next part, which is the start timer. For the start timer, once the echo signal starts, the timer is started by loading the register 0 with 1 and storing the register 0 to the memory location pointed to the register 11, which is the address for the TC, the timer control register. Then we'll go into the read one. The read one is another loop that wait for the echo signal to end. It does it does the same operation for the read loops, but the time is continued looping as long as the result of the comparison is equal to the R1 and as long as the echo signal is still high. Next, we will be have the stop timer. Once the echo signal ends, the timer is stopped by loading the register 0 with 0 and storing register 0 to TC with the timer's controller, and then timer control register. And then next we will go into the read timer. The timer value is then read by loading the R3 with the value at the memory location pointed by R12, which is the address of the TR, the timer register. Then we will clear the timer. The timer is cleared and by storing the value of register 14, which is the link register, and content 0 in this context to TR. After that, we'll start to calculate the distance. The timer value is compared with the 600. The 600 there is calculator for the formula which is the distance is equal to 2 times the distance that the maximum distance that you want. For example, in this in this system, we assume that the maximum distance that captured is 10 cm. So we put the 10 cm in. We add the 10 cm 2 times 10 cm over the speed of the sound. That we will get a count. Uh, the the count value for the distance which is the 600. So if it's the less than or equal to the 600, the branch to the it was branch to the detector, and if the more than 600, they will branch to the not detected, which is the object is not detected. This is the coding for the detector loop and not detector loop. If the object is detected in the range of the distance, so the green LED will be off and will turn on the LED and the buzzer. And we also have the delay time for the alarm. Then after that, if the object is not detected, we will turn off the red LED and also the buzzer and turn on the green LED. After these detections, the loop will be continued to run to constantly to checking the presence of an object and provide the visual and auditory alarm accordingly. Thank, thank you.
Ini awak-awak nak modify ni. Ini awak itu yang awak abang tak apa lah. So from the video previous slide, which is the project demonstrations, initially the system will lit up the green LED light and the buzzer and red LED light will be off state. And in this testing, the object that we use will be human hand. So in situation 1, the distance of object and the system is in the range of detection which is less than 10 cm, and the result will be the buzzer and red LED light will be on and the green LED light will be off. And in the situation 2, where the distance of the object and the system is out of the range of detection which is more than 10 cm, and the result will be the buzzer and red LED light will be off and the green LED light will be on as same as initial state. So this system will immediately change the status of the result according to the situation detected by it or the ultrasonic sensor. Result. In this slide, the picture shown is the circuit that constructs the system in the lab. So the timer coding is being tested using CAD software through a debug session where there are 4 breakpoints stated at the line coding of line 80 and 91, where they have the same coding which are the SDR, R0 and R11. Line 94 where the coding is LDR, R3 and R12. And lastly, line 97 where the coding is SDR, R14 and R12. The purpose of this testing is to observe and prove the address and value in each of the register are the same as what is required by the coding part of the timer. So the situation used in this testing is the distance of the object and the system is in the range where it is less than 10 cm. Result first breaking point. So the first breaking point is located at the coding part of the command start timer. So the expected result that needed by the coding is the register R0 should have the value of 0 and 01, and the register R11 should have the address of timer control register TC, where the address is 0 times 4000 4004. Hence, the result that we get is same as the expected result as shown at the left side. Result, second breaking point. Initially, the register R1, which is the register for echo, will be in 0 times 10000000. This is because initially we would like to activate the echo, so in the pin of the echo there will be value of 1. So for this situation, the value of R1 will be 0 times 1, 2, 3, 4, 5, 6, 7. This is because in this situation, the distance between the object and the sensor is in the range which is less than 10 cm. the reflected signal that received by the echo will be in shorter time. So the value that received by the register R1 will be high value. So the expected result is the register R0 will be the value of 0 times 0 and the register R11 will be same as before. So the result that we get is same as the expected result as shown beside. Result, the breaking point. Expected result is the register R3 should have the value of register R12, while from the previous slide the value of R12 is 0. Hence in this slide the register R3 will be in 0. So for B, the register R12 should have the address of the timing register TR, which is 0 times 4000 4008, and the result that we get is same as the expected result as shown beside. Result, probe breaking point. So the expected result is the register R14 and R12 should be same as before. So the result that we get is same as the expected result as shown besides. So at breakpoint 5, the way of coding is towards the coding part of detector, which is shown as the green color at the picture besides. This proves that the flow of the coding is same as the way of the situation used in this test, which is the distance of the object and the system is in the range which is less than 10 cm. So it will towards to the coding that will activate the buzzer and red. Conclusion: this project presented a collision detection system using CAL programming software which is based on the mbed LPC1768 microcontroller. So this system is inexpensive, or we can say it as cheap, because the component used is less and also the price is affordable for everyone. So this project can be said is successful because the system is functioning and working correctly. So it may benefit to all the users in the world and decrease the percentage and reduce the car accident that occur in the world. That's all from us. Thank you.